Hello dear students of plus 2 medical, non-medical and respected teachers. Today's topic is Ohm's law and resistance. So let us start. What is Ohm's law? It states that potential difference V across the ends of a conductor or a wire is directly proportional to current flowing through the conductor. That is V proportional to I or V is equal to IR under similar conditions of temperature and pressure. V is equal to IR. Where R is known as constant of proportionality and this constant is called resistance of the conductor. Or R is equal to V upon I. So resistance of the conductor is nothing but opposition offered by the conductor to the flow of current. And mathematically, resistance of a conductor is defined as the ratio of the voltage or potential difference across the ends of the conductor to the current flowing through it. So, if V is in volt, current is in ampere in SI system, the units of resistance will be volt per ampere or ohm. So, ohm is the unit of resistance in SI system. In other words, resistance of a conductor is said to be 1 ohm if 1 volt potential difference produces a current of 1 ampere. Now, how to prove Ohm's law? Question may be asked, state and prove Ohm's law. So, to prove Ohm's law, that is to prove V is equal to IR, we have derived relation between electric current and drift velocity. I is equal to NEAVD. And also Vd is equal to EE by m into tau in magnitude. Substitute the value of Vd in terms of electric field in this equation. So we have I is equal to NEA. Instead of Vd we write EE by m upon tau. It will be NE square tau by rearranging upon m V upon L into A. Or from this equation we had V upon I m upon NE square tau L upon A. And this is constant. This right hand side is constant provided temperature is constant and for a given conductor. For a given conductor, that is N, A, L are constant and tau is constant if temperature is constant, elapsing time. So V upon I is equal to constant. This constant is called R. So this implies V is proportional to I or V is equal to IR, which is nothing but Ohm's law. So we can prove Ohm's law in this way. So R, expression for R comes out to be m upon NE square tau L upon A, or R is equal to rho into L upon A, where rho is equal to m upon NE square tau, and this rho is called specific resistance or resistivity of the conductor. So rho is equal to m upon NE square tau, and units of rho will be ohm meter. So we substitute the value of length meter, area meter square, so it will be 1 by meter, so it will be ohm meter. So resistivity has units of ohm meter in SI system. Now, if L is equal to 1 unit, say A is equal to 1 unit, then rho will be equal to R. It means what is resistivity? Resistivity of a conductor is nothing but resistance of unit cube of the conductor. So if we have unit cube of the material of the conductor having length 1 unit, area 1 unit, then total resistance of that unit cube for that particular conductor will be called its resistivity. It means resistivity is independent of dimensions of the conductor. It will not depend upon length or area of cross section because it is a resistance of unit cube only. So resistivity is independent of dimensions of the conductor, but it depends upon nature of the material of the conductor as well as temperature of the conductor. Now, from this equation, we can find the factors upon which resistance or resistivity depends. From this equation, R is equal to m upon NE square tau L upon A. Resistivity is constant for a given conductor at constant temperature. It means resistance is directly proportional to length of the conductor. More is the length of the conductor, more is the resistance of the conductor. Number 2, resistance is inversely proportional to area of cross section of the conductor. For a given length, if thick is the wire, less will be the resistance. So resistance is inversely proportional to area of cross section of the conductor, that is thickness of the conductor. Third, resistance as well as resistivity depends upon nature of the material of the conductor. So resistivity does not depend upon length or area of cross section, but resistance depends upon length and area of cross section of the conductor, whereas both R and rho depend upon the nature of the material of the conductor. Fourth factor is temperature. So resistance depends upon temperature, and hence resistivity also depends upon temperature. And if R0 is the resistance of the conductor at 0 degrees Celsius, RT is the resistance of the conductor at T degrees Celsius, then RT is equal to R0 into 1 plus alpha T, or alpha is equal to RT minus R0 upon R0 T. That is alpha, that is known as temperature coefficient of resistance. Temperature coefficient of resistance is defined as the change in resistance per unit resistance per degree rise in temperature. And for metals, alpha is positive. It means resistance of metals will increase with the increase of temperature. For alloys, alpha is also positive, but it is comparatively very small. So resistance of alloys increases with the increase of temperature, but by very small amount. And for semiconductors and electrolytes, alpha is negative. So resistance of semiconductors and electrolytes decreases with the increase of temperature, because alpha is negative. This term comes out to be negative. This is how resistance or resistivity depends upon temperature. Then, what is the cause of resistance? We have defined resistance is the opposition offered by the conductor to the flow of current. So what happens when current is passed through a wire or a conductor? The electrons get accelerated due to the electric field or potential gradient. As a result, they acquire speed and acquire kinetic energy. But the kinetic energy is lost at every collision. In other words, free electrons of the conductor has to collide with the atoms or molecules of the conductor inelastically. So, inelastic collisions of the free electrons with the atoms or molecules of the conductor is the cause of resistance. That's why conductor offers opposition to the flow of current, and that loss in kinetic energy appears in the form of heat. That's why wire gets heated when current is passed through wire or the conductor. So this is the cause of resistance in elastic collisions. Then what are ohmic and non-ohmic devices? The devices or materials which obey Ohm's law, they are called ohmic devices. That is, for which graph between V and I is a straight line, they are called ohmic devices. So all metals are ohmic devices. Non-ohmic devices for which V is not proportional to I, that is, which do not obey Ohm's law, are called non-ohmic devices. For example, semiconductors and electrolytes are non-ohmic devices. Then the definition, what is conductance? Conductance is the reciprocal of resistance. Reciprocal of resistance of a conductor is said to be reciprocal resistance of a conductor is said to be conductance. The units of conductance will be Ohm inverse, or Ohm inverse is also known as Mho or Simon. So Mho or Simon is a unit of conductance. So conductance of a conductor is said to be 1 Simon or 1 Mho when its resistance is 1 ohm. Then what is conductivity? Sigma. Conductivity is defined as the reciprocal of resistivity. So conductivity from the name is the reciprocal of resistivity. That is, sigma is equal to 1 by rho, or n e square tau by m, which is required expression for sigma. Or units of conductivity will be sigma inverse meter inverse, because units of rho are ohm meter. So it will be ohm inverse, meter inverse. Sigma stands for ohm. So, or it will be Maho per meter or Simon per meter. Then we can find relation between J, that is current density, sigma, electrical conductivity and electric field. So similarly, as I is equal to NEABD, such the value of BD in terms of electric field NEA EE by M upon tau, or simplifying it, it will be NE square by tau upon M. I by A is equal to NE square tau, again ऐसी NE square tau upon M into E, and NE square tau by M is nothing but 1 by rho, and 1 by rho is nothing but sigma. So I upon A is nothing but current per unit area, is called current density. So J is equal to sigma I, which is another form of Ohm's law. So Ohm's law is stated in two ways. V is equal to IR, the same expression. If we take I upon A from this equation in terms of electric field. So current density is defined as current per unit area, or J is equal to sigma E. This is another form of Ohm's law. So you will be asked, derive J is equal to sigma E or derive V is equal to IR. So this is all about Ohm's law, and I think this Ohm's law and resistance is very simple topic, but very important topic, because it has so many applications, and we will study further the whole chapter of electricity. So be happy, all the best, and